Hello and welcome to the lesson on angle relationships. Today we're going to look at how to classify angles and how to manipulate and use some of the relationships that are given with particular angles. So to begin with, we're going to look at classifying angles. The first thing we need to know is if you have an angle that is less than 90 degrees, as you can see pictured right here, this is what we call acute angle. Okay, so it's less than, or it's small, so it's really teeny tiny and it's cute. So again, if it's less than 90, this is what we call an acute angle. If we have an angle that is right at 90 degrees, as you can see here, usually it's shown with this little square in the corner to show that we have a 90-degree angle. And this is sometimes also referred to as a right angle. So right angle really just means a 90-degree angle. If we have an angle that is larger than 90 but less than 180 degrees, this is what we call an obtuse angle. So again, obtuse means that it's somewhere in between 90 and 180 degrees. So you can see that right here. And finally, we have something called a straight angle. Now, a straight angle actually creates a straight line, and the angle measure of that straight line is equal to 180 degrees. So now let's take a look at a few relationships that we have with angles now that we know how to classify them. The first thing we're going to start out with is talking about an adjacent angle. An adjacent angle shares a vertex and a side, but no points in their interiors. So notice right here, it tells me that angle AXB or AXB and BXC are adjacent. And that's because this is one angle here, here's another angle. They share a side, but no points on the inside. So these are what we call adjacent. Now notice it tells me that AXC and BXC, these are not adjacent because BXC is actually inside of AXC. So that's why this right here is not true. We also have something or a relationship called vertical angles. This is when you have two intersecting lines, and the vertical angles then are going to be the angles that are opposite of each other, or the vertical angles. So if you notice that angles 1 and 3, so 1 and 3, these are vertical because they are opposite of each other, just like 2 and 4 are opposite of each other. Now, angles that have the same measure are what we call congruent. So in the first diagram, in the diagram that has the numbers in it, we say that angles 1 and 3 are congruent because they're vertical angles. And the little equal sign with a squiggly above it, this shows that it's congruent. And we write that as angle 1. And if we want to be specific with the measurement, then we can put M, which means measurement. So we say the measurement of angle 1. Okay, so we could say that angle 1 is congruent to angle 3, or we could say the measurement of angle 1 is equal to the measurement of angle 3. We also have two other relationships that get used quite a bit. And it says, the first one says, if the sum of the measures of two angles is 180 degrees, then we say that these are supplementary. So if I can take two angles and add them together, then they equal 180, then these are supplementary angles. And just like with supplementary angles, we have a term used when we have two angles that add up to be 90 degrees. This is what we call complementary. Now these are sometimes confused easily. Okay, so what I like to do is I like to think of complementary and supplementary are alphabetical. Usually we come to complementary first in the alphabet, just like we come up to the number 90 numerically first before we get to 180. So I always think about complementary and supplementary kind of like as something as being alphabetical. Complementary and complementary and 90 degrees go together. So two angles that add up to 90 are going to be complementary because 90 comes before 180, just like C comes before S. Likewise, Supplementary angles are two angles that add up to be 180 because S comes after C in the alphabet, just like 180 comes after 90 and the number line. So for example 1, we are going to list adjacent angles. So adjacent angles, remember, are just two angles that are next to each other. So I could say that angles 1 and angles 2. So I'll say 1 and 2. We can say angles 2 and 3. We could say 3 and 4. Or we could go ahead and say 4 and 1. These are all adjacent angles. Now for vertical angles, we have angles, remember, that are opposite of each other. So for one set of vertical angles, I could say 2 and 4. And I could say that the other set of opposite angles are going to be 1 and 3. And for supplementary, remember, supplementary are two angles that add up to 180 degrees. So there's multiples of these. I could say angles 2 and 3. We could go ahead and say 3 and 4 are going to be 180 degrees. We could say that 4 and 1 are, or I could go ahead and say that 1 and 2 are as well. So 1 and 2. Now right here are a couple properties that we're going to go over that are very important and will help us find measurements. Okay, so when you have a transversal that intersects two parallel lines, so here I can see that L and M are parallel lines, and I'm told that right here. I have this line that's going through them, and this line is what we call the transversal. So if a transversal is intersecting two parallel lines, then we have the following items are true. So first of all, we have corresponding angles are congruent, which means that they're the same. So angles lie on the same side of the transversal in the corresponding locations. So if I look at, let's say, angle number 1, well, angle number 1 is on the same side of the of the parallel lines as angle 3. So I could say that angles 1 and 3 are going to be the same because of corresponding angles. Okay, likewise, we have angles 8 and angle 6. Okay, so I could say 8 and 6 are corresponding because, again, they're on the same side of that transversal, or of the two parallel lines. I also have angles 2 and 4, and we can even go ahead and look at 7 and 5 as being congruent. Okay, the next property we have talks about alternate interior angles. So for alternate interior angles, it says these are angles that are on opposite sides of the transversal. So in this case, we have something like 2 and 6. So 2 and 6 are considered alternate interior, because alternate meaning that they're on the different sides, interior meaning that they are on the inside of the two parallel lines. So 2 and 6. And so if 2 and 6 are alternate interior angles, so is 7 and 3. So we could also put down angles 7 and 3. Now we have the same property for alternate exterior. The only difference is that exterior means that we are on the outside. So for our alternate exterior angles, I have 1 and 5. And I also have 8 and 4. And the final property that I have is what we call same side interior angles. And the same side interior angles are, these are said to be supplementary, which means that they add up to 180 degrees. And these are the angles that are on the same side of the transversal and in between parallel lines. So to look at this, that would be like angles 2 and 3. So these are supplementary. So 2 and 3. And that would also mean that 7 and 6 are also the same side interior angles. So 7 and 6. So we are told to find the angle measures given. So I have angle measure 1 and 2 in the first image. And right away, what I like to do is I like to look at my relationships. So I know that this angle right here and this angle in here for number 2, that those actually need to add up to be 180 degrees because they are what we call supplementary. So I'm going to put supplementary, and that means that I have 180 minus 75 is going to give me that angle 2. So 180 minus 75 is actually 105 degrees. So I found angle 2, and there's a couple different ways that you can find angle 1. But I think the easiest is going to say that they're corresponding. So angle 1 is corresponding to the 75 degree angle. So I'm going to say that this is 75 degrees because of corresponding. And again, there's multiple ways that you can find these. For figure 2 here, I have to find angle 1. And I see that I've got this angle here and this angle here. Now, AB and DC are parallel, and I can tell that because of this little triangle shape right there. So because those are parallel, the 80 degree angle is actually going to be an interior angle. So I know that for angle 1, if I go 80 plus X, this should give me 180 degrees. So that tells me then that angle X is going to be equal to 100 degrees. And for angle 2 here, let me change my color. So for angle 2 and angle 70, the relationship here is that these are going to be alternate interior. So because they're alternate interior, then that tells me that 70 and 2 are the same. So angle 2 is actually 70 degrees. And then when I look at my final picture here, we have a lot of stuff going on. So I like to start out with things like vertical angles and stuff like that first. So right away, because I have this 50 degree angle on the inside, I know that angle 8 is also going to be 50 degrees. And because of alternate interior angles, if 8 is 50, alternate exterior, if 8 is 50, then 5 is also 50. And if 5 is 50, then that tells me that 1 is 50. And let's see. If 8 is 50, then I also know that 6 is 50 because they're on the same side of the parallel lines, or they're corresponding. So 6 is also 50 degrees. And I think that's all I have on that. The rest of these look like they're obtuse angles. So what I'm going to do to find my obtuse angle, I'm going to use the fact that angles 7 and 50 are what we call supplementary. So if I go 180 minus 50, that gives me 130 degrees. So angle 7 is 130 degrees. And if 7 is 130, then I know that 2 is, because these are corresponding. And if 2 is 130, then 4 has to be, because these are alternate angles. So 4 is 130 degrees. And if 4 is 130 degrees, then so is 3, because 3 and 4 are vertical angles. So if you look at that, I was given one angle measure, which was the original 50 right here, and I was able to find 8 other angles based off that one measurement. We will have more practice with this in class. Please let me know if you have any questions. Otherwise, I hope you guys have a great day.